Okay, in this video we have another example. It is another right triangle, but in this case we know only one side. We know side little a. We don't know side b or side c, so we can't use the Pythagorean theorem just yet. However, we do know two angles, angle alpha and angle gamma. So we can use the law of sines to then solve for one of the missing sides here. And let's go ahead and do that. Let's solve for side C. So we're going to solve for side C, and we're going to use the law of sines to do that. The law of sines says that sine of gamma over little c would have to equal, and we're going to use, in this case, alpha and a, sine of alpha over little a, so that we have only one unknown in this process, and that is c. So sine of 90 degrees again is 1, so I have 12.7 is equal to sine of 25 degrees times c. So c would be equal to 12.7 divided by the sine of 25 degrees. I'm going to use my calculator. C would be equal to, again, 12.7 divided by the sine of 25 degrees, sine, and I'm just going to double check to make sure that I'm still in degree mode. I am. Put out of that, sine of 25 degrees, and that gives me 30.0507. So I'm going to type that in for C, 30.0507, and I'll round that up to 1, and we are correct on that. Alright, so we now have two angles and two sides. I can, let's see what I can do at this point. I can't use the law of sines again to solve for beta or b, because those are two unknowns. I would have sine of beta over b is equal to sine of alpha over little a, and since the right side is a constant, the left side has two unknowns, and I wouldn't be able to solve for that. But at this point I could use the Pythagorean theorem to solve for the final side. So I'm going to solve for side b using the Pythagorean theorem, and I know that I'm going to start from the hypotenuse, that little c squared is equal to b squared plus a squared, and I would find that on my calculator one more time by using 30 squared minus 12.7 squared, 12.7 squared, and that is equal to 738, and I want the square root of that answer, and that will give me 27.179, which I enter here, 27.179, check, and we're good to go with that. Now we can solve for beta using the law of sines. So we're going to solve for angle beta using the law of sines, because I know that sine of beta over b, which I now know, is equal to sine of, and I'm going to use gamma since that's an easy calculation, over little c, and I bring in my calculator at this point, and sine of beta times 30, so 30 sine beta is equal to 27, so 30 sine beta is equal to 27, so I'm going to divide 27.2 by 30, and I get 0.90666. When I take the inverse sine of that, I get 65.048, which when I enter it into the answer box on the screen, I get a correct answer. And so we've solved for all the sides and all of the angles there using the law of sines and the Pythagorean theorem. Again, another example that may help you. We've only seen right triangles in here, but I think that it should be helpful, and you could continue to use this to see what you'll get.